I'm here with Dan Henrich, President and Founder of PDE Total Energy Solutions. Dan, can you explain to our viewers what exactly is a smart microgrid system?
A microgrid system is a system of a combination of renewable energy sources with energy storage that can either be grid connected or act independently of the grid.
Now, who would be the best candidate for a smart microgrid system?
Multiple candidates. It can be municipalities, it could be hospitals, it can be schools, it can be businesses that, again, where you have renewable energy sources to save energy, but also if you lose the grid, you can still continue to operate. And you can feed multiple sources, or it could be an emergency source or a critical power source such as a data center or servers, or in a hospital, an operating room, or refrigeration equipment.
How does a smart microgrid system integrate with other established electrical systems?
Again, it operates in tandem. You can store energy, you can sell the excessive energy solar to the batteries. You can then store that and sell it back to the grid. You can use the power from the grid when you're buying the power, when the power is at its lowest cost. They'll interact together. If you lose the grid, again, it will act independently and continue to keep a building or a particular source online.
Can you tell us what is new about this technology?
Well, what's new about it is the integration of tying all of this technology into one system, which is the microgrid. You have solar, you can have wind, you can have a fuel cell, electric vehicle charging stations, and tied all into one system with energy storage. And energy storage is one of the key components. It's been around for a long time. We did our first megawatt of energy storage. It was 2.2 megawatts over 20 years ago. That system is still online. We still maintain that system for a large telecom company. And that's what's new, is that the new technology is lithium-ion, new energy storage systems, flow batteries, and also still lead acid. So batteries are complicated, and that's one of the keys to this project here, is that we want to educate our electricians and the contractors on energy storage and the installation methods. And it's critical that these systems are installed properly so there's no downtime, which obviously has an economic impact, and also for the installation methods, safety, which is associated with all of these systems being installed together, and then the curriculum that comes out of what we're doing here with this first microgrid system to train the future electricians, so the NECA contractors can hire those electricians, install those systems, and they're being installed by certified IBW NECA contractors. So there's confidence that the systems will stay online and that they can be maintained properly.
What type of training does it take to operate this kind of system, and what kind of training do you offer?
Well, here at the ETI, the Electrical Training Institute, the reason we've produced and designed and built this smart microgrid project is to train the electricians. And the new systems are electric vehicle charging systems, which is part of the electric vehicle infrastructure training program. There's solar, of course, which is already being taught. But what's new with all of this is the energy storage systems, the batteries. The electricians of today need to be trained in the DC power and energy storage system. So that's new. And then, of course, what is a microgrid? How does it all get interconnected? And then how is it controlled? And that's what we're demonstrating and teaching here through this project, the Smart Microgrid project at the ETI.
In regards to energy independence, how important are these microgrid systems?
Well, it's extremely important. It's the key. The future for energy in this country is zero net energy. Buildings will in the future produce as much energy as they use, and they'll also be able to operate independent of the grid and also be connected to the grid. And proof of that is legislation is supporting energy storage systems through tax incentives. They're supporting the Electric Vehicle Infrastructure Training Program and NEMA, National Electrical Manufacturers Association, and methods of installation, along with electrical safety associated with all of these systems. The whole industry is coming together to support renewable energy, microgrid systems, and zero net energy.
Now we are going to speak with Dan Cohee about an operating microgrid system. I am here with Dan Cohee, Vice President of Operations at PDE Total Energy Solutions. We are here at the IBEW and NECA training facility. Hi Dan, can you please explain to us the major components of a microgrid system?
Absolutely, Shelley. Typically, game-changing technology that you'll see in the year 2020 advanced electrical systems are going to be incorporating bidirectional inverters, advanced battery technologies, and advanced control systems coupled with renewable energy sources, which we have here at the Electrical Training Institute.
Can you please explain the components of a microgrid system?
Absolutely. Microgrid systems consist of a bidirectional inverter, which has the ability to synchronize with the local utility grid. It also has the ability to island or isolate itself from the local utility grid. It has the ability to have multiple generation sources such as solar, wind, or fuel cells also tie into the inverter. So the inverter then can either sell excess energy back to the utility, or it can take those renewable energy generation sources and island from the grid, disconnect from the grid, and also power the building or critical systems seamlessly. There's also a major component of that is advanced batteries now. You see lithium-ion batteries, you see thermal batteries, sodium batteries, you see lead-acid batteries, you see flow batteries. All of these new battery technologies are also incorporated into microgrids, and they're used to buffer the intermittency, and smooth out the production of the renewable energy to sustain a microgrid when the grid is not available. And a third component that you always see is an advanced control system, either using a PLC, a programmable logic control, which we use in this system here at the Electrical Training Institute, or you use a domain controller that can also control multiple smart devices and interact with other building systems to interactively act to provide a more reliable, efficient electrical system.
So what kind of companies will benefit from this microgrid system?
Oh, multiple different companies and industries will benefit from smart microgrid systems, namely the telecommunications industry, the commercial building industry, the manufacturing industry, military industry. Anyone who wants to have lower utility bills, wants to have more reliable power, wants to have the ability to integrate smart technologies into reducing their overall economic cost of electricity and operational cost of a building should be incorporating microgrids into their buildings.
Now, I understand you're working on the largest microgrid system in the country. Can you please go into detail about this?
Yeah, currently PDE Total Energy Solutions is integrating a 576 kilowatt energy system to a 10 megawatt microgrid system at the 29 Palms Marine Corps Air Ground Combat Center, which is the largest military microgrid. The purpose of the project is the Department of Defense is evaluating the ability of an advanced battery to allow the over 1 megawatt of solar to stay online during a microgrid event. So if the utility fails, the military's one of the prime deliverables is the ability to use the solar power when the grid is gone. And currently they cannot do that because of the effects, the intermittency of solar. They're also evaluating the economic benefits of using batteries to reduce their energy consumption through power factor efficiency and through volt-var control.
Now, Dan, can you show us how this system works?
Absolutely, Shelley. Let's go to the microgrid control screen and I'll show you how the system is operating right now.
Now, Dan, can you explain to us what we're looking at?
Yeah, currently we're looking at the 3D graphical interface of the microgrid and the mode that we're running in. Currently we're running in an energy optimization mode. So if I look at the control screen, the facility right now is selling 87 kilowatts of energy back to Southern California Edison right now. So the facility right now is generating more energy than it is using. It's also, if you notice, there is we are using approximately 1 kilowatt of battery to sell back to the grid right now. We are producing solar that is also providing energy directly to one Chevy Volt out there that is charging at a rate of 3 kilowatts. So the cars are charging right now completely without any Edison energy, straight off of the solar. We're also providing power directly off the solar and the batteries to the data center that's located within the facility right now. So you're seeing an example of a system that can sell energy back to the utility, can charge cars with 100% green energy, and can provide 100% green energy at times of the day to the data center, all happening at the same time.
Say I'm a manufacturer and we have a major power outage. What is the benefit of your microgrid system?
Well, the benefits of our microgrid system is it will be able to provide continuous power through the power outage interruption to allow manufacturing or typical business operations to continue. It will also allow the renewable energy sources, which typically, per Rule 21, has to stop producing. Our system will island or disconnect from the grid and continuously allow the power to produce. So if there's wind or photovoltaic, you can use that energy and you can drive it into your business. So if you need to keep manufacturing, you can operate without the grid, straight from the solar and the batteries continuously. Then when the grid returns, the smart microgrid system will seamlessly synchronize back to the utility grid without interruption to any business operations to seamlessly allow businesses more reliable, more efficient, incorporate green energy, and be more profitable.
With the country's need for energy independence, where does your microgrid system stand in the future?
Oh, this is a system that is going to participate in the future of our electrical infrastructure. With the legislative mandates going for net zero energy buildings, buildings are going to require smart energy systems such as this that can combine renewable energies, can combine batteries, can harvest and store energy and take that energy and distribute it throughout 24 hours a day. All buildings will be required to have some sort of smart energy microgrid system similar to what you see today in this building.
Thank you for your time, Dan.
Thank you very much.